guys. Good morning, everyone. It's very nice to see you guys here. And let's talk about security and serverless. But first, let's talk about the one thing that I want to talk about more than serverless and security, myself. So I'm a principal engineer at a company called Zone, and since July, I've also been one of the Amazon's serverless hero, which just means I get a free ticket to reInvent this year, which is pretty sweet. And at Zone, we are a sports streaming platform. We do both live sports as well as sports on demand. And right now, we open in 7 different countries with about 6 or 7 million subscribers globally. You pay a monthly fee similar to Netflix, hence why we often call ourselves Netflix for sports. At peak, we get about 1 million concurrent users, so there's some very interesting technical challenges there to support that kind of load that we have. If you find out a bit more about what excuse me, what jobs we have available and what we're doing as a team, you can follow us on Twitter as well as check out engineering.zone.com because we're also hiring as well. I'm pretty sure like everybody else here. So personally, I've been using AWS for about almost 10 years now. And in one of my previous companies, I worked on a non-trivial serverless architecture whereby we migrated a social network to run pretty much entirely on serverless. So along the way, I learned a lot about all the different things you've got to learn to make sure you can actually run your production workload on this new technology. So when you go to AWS, you've probably seen this chart already in terms of the shared responsibility model, whereby what security that Amazon takes care of and what security that is still your responsibility. And traditionally, you are responsible for operating systems, the networking, and firewall configurations. But of course, when you go to serverless, Amazon is taking care of more of the infrastructure for you, including the security around the operating system and networking and so on, which for me is great news because as an application developer, I just don't have time to constantly thinking about, okay, when should I update when should I patch my OS, when should I update my firewall settings and so on and so forth. And having Amazon do that for me just means that I get a lot better protection in return without doing anything myself. So I also don't have to worry about attacks against the OS like the WannaCry, or in fact, when the whole thing went down with Meltdown and Spectre, and everybody else was busy patching their servers and machine images and whatnot, all my functions got patched. I even forgot about it, and then the next day I go to Twitter and I see Chris Mums put a tweet say, all the Lambda functions has been now patched for Spectre and Meltdown, which is great. Again, it's all these extra things that get from the provider without having to do anything myself. However, my code is still my responsibility along with all the dependencies that my code has. And if you look at the last OWASP top 10 list we got from last year, pretty much everything is still the same at the top. It's crazy how injection attacks are still #1 after 10 years. And when the guys from Snike looked at the top 50 biggest data breaches that happened in 2016, they found that a quarter of them was caused by applications using components with known vulnerabilities. So these are things that can easily prevent just by updating your dependencies. Sorry, feel free. The slides are going to be available afterwards anyway. And in another article, they looked at the some of the top 1,000 websites based on Alexa ranking and found that almost 80% of them was using some libraries that has known vulnerabilities. And it's not surprising when you look at that even some of the biggest front-end frameworks like jQuery and React had some vulnerabilities at some point in time. Of course, they were patched in the later versions, but then it's still up to you to make sure that you are using a later version that do not have those known vulnerabilities that people can attack you with. And then there's also libraries like User Agent, which at one point I think had a vulnerability to the regex denial of service attack as well. And of course, even when you go into serverless, even though you don't have to worry about servers anymore, it doesn't mean that you are safe from the classic SQL injection attacks. So if you're using, say, MySQL or Aurora or whatever kind of SQL database from your Lambda function, you still need to worry about SQL injection attacks. You still need to sanitize the inputs and protect yourself accordingly. And even when you're using those SQL databases, turns out MongoDB, you can still attack it using its query syntax. And then, so the takeaway from that is that even though you're working with serverless, you still need to think about all the same application level attacks as before. And SQL injection is still very much one of the easy things that you can take off. And the GraphQL has also been getting a lot of popularity over the years. And I was really surprised as when I was getting into GraphQL to find out that actually someone managed to do an injection attack against GraphQL as well. Which I guess when you think about it, it's probably not all that surprising, because ultimately your GraphQL query gets translated into some request to a web server that executes some query against a SQL database. So you can work out how the transformation happens. You can still inject attacks. You can still do injection attacks against the GraphQL endpoints. And also found this very nice little article about how there was code injection vulnerability to one of the libraries that LinkedIn published. So I guess you just can't trust anyone these days. And of course, that means you have to constantly update your dependencies. And if you're really unlucky, you're going to patch your application, so your dependency to a version, and you're going to fix a whole bunch of vulnerabilities that it has. And you're going to find yourself in another world whereby the later versions now has new vulnerabilities. So you have to constantly do this exercise. And if I guess the morale of the story is that your application dependencies is probably a lot bigger attack surface than you probably realize. For starters, you've got your own dependencies, but that's just the tip of the iceberg, because underneath that, there's a whole lot of dependencies that your dependencies depend on. If you just take a look at any number of popular packages, whether or not it's Node from Node.js for Java, you're going to find the same thing, where there's a very deep tree of dependency. In fact, it's so much so I love this. By the way, we've got the same name, but that's not me. And obviously, she gets a lot more retweets than I do. And of course, I guess what I'm trying to say here is that we should use services like Snag to try to automate this process of scanning our dependencies and alerting us when we have known vulnerabilities in our dependencies, including all the transient dependencies that we have as well. I also noticed that Git has been doing this for a few months now. So when you go to your GitHub repo, it sends you a report of what known vulnerabilities that you have in your dependencies. But the thing I find about patching application level dependencies compared to patching your OS is that when you get those security updates for your OS, they tend to be self-contained, and it's so nice and easy to apply. But when it comes to application dependencies, especially with frameworks, oftentimes the known vulnerabilities are only fixed in the latest version, especially when you have major version updates. So if you're using, say, version 1 of some framework, and then there's some known vulnerabilities, chances are, if it's open source software, then the fix is only available in version 2, which is often not an easy fix update, because it's breaking changes and often involves API changes that you need to plan and integrate into your application, as well as integrate with the rest of your team. And your security chain is as strong as the weakest link. And when you look at, for example, if I look at any one of my functions, it's going to depend on the bunch of libraries. It's going to have a bunch of users, and it's also going to run on AWS. So all of that is taken care of by AWS. And of course, if you're watching a movie, then I don't know why they always do this, but they always want to attack the physical infrastructure where that are guarded by armed guards, and they're going to do the Tom Cruise and sneak in for some reason. Everybody knows all the systems that they've never seen before. They know how to hack it exactly in 2 seconds, and then they're going to walk away and just blow things up, punch a few guards, and just look like a boss. But as an attacker, of course, I'm not going to go anywhere near the physical infrastructure. For one thing, I'm going to leave my bedroom. Who want to do that? So, especially when there's so many low-hanging fruits, I can just attack against your dependencies or against your application directly. And of course, we probably all know this, that humans are often the weakest link in any security chain. And I'm sure most of you have seen the Mr. Robot. If you haven't, go check it out. There's only I think there's 3 seasons now. It's great. And if you see most of the attacks that they do in the show, none of them are very technical. In fact, most of the time, they just do very simple social engineering against the users of some application. I think one episode, Dali just dropped the USB key near a police station, and the policeman picked it up, plugged it in his laptop, hey, free USB key, and then they can run some code as soon as the USB key is plugged into the machine. And of course, you can attack the developers for the application as well. Maybe they are leaving their GitHub credentials somewhere in the public repo somehow. So you can if you can get into their account, then you can access any software that they are responsible for, including the ones that are potentially used in your organization. And also, they can also attack the authors for the dependencies that you use for inside your software. So this happened last year, and I think it was amazing that a security researcher was able to gain publish access to 14% of all packages on NPM at the time, which included some of the most popular packages that you find in the Node.js space. So in total, the packages that he was able to gain published access to accounts for something like 20% of total number of downloads in NPM on a monthly basis. So that is pretty scary. In fact, this could have happened already. We just didn't know about it. We're lucky that someone did this and tell us, hey, there's this massive gap in your security chain because the people that are writing the software that your software depends on is not doing a very good job in protecting their NPM accounts. And the security researcher used basic methods. He didn't use anything crazy, just simple brute force and using known account leaks, so credential stuffing, and sometimes he even found the NPM credential just left hanging there in a public repo. So, and when I read a summary, another thing I found was this is crazy. Like 1,000 people developers were using passwords like 123 or password. I mean, surely as developers we got to know better than this, right? So it's really, when you look at things like this, it's really hard not to feel let down. And when you think about what actually goes on inside the execution environment for my Lambda function, hey, guess what? I've got a bunch of really useful environment variables in my Node.js, in my Lambda execution environment, including the AWS access key, secret, security token. So all the information I need to get access to your AWS account, if I can get into your function. So I thought about, hey, as an attacker, how can I actually get into your function? Well, it turns out if I just publish a package that you may want to depend on, so as an experiment, I put something on an NPM with a name that you clearly should not download. And to my surprise, like a week later, I went to the NPM package, I found over 200 downloads. God help us. So as a part of the experiment, I set up my package all it's doing is that the initialization time, I'm gonna scan everything that's in your environment variables, and then I'm gonna publish to some endpoint that I've set up. And then in that endpoint, it's just a simple API gateway with Lambda. I'm gonna look at what's coming, and then if that payload contains the AWS credentials, great. I'm gonna send a message to SNS so that I can get a notification through SNS to my email. And the main thing here is I'm looking for just those guys. Potentially, I can even look for database usernames and passwords and so on as well. And so that works beautifully. It took me like 15 minutes to set up. And I was able to use the credentials. I email myself to gain access to my own AWS account to list the contents I have in my S3 S3 buckets. So that's not great. That's way too easy. And so I checked, okay, what happens if it's a transient dependency? So it's not something that I depend on directly. So I put in the package there, also with a rather ominous name. Again, people just keep downloading this stuff. I don't know why. And then again, it still works. So it's just, oh my God, it's too easy. And it turns out, and later on, after I did this, I published this, and then I found out like a week later, something else happened. You don't even need to compromise an existing package. What you can also do is just apply simple social engineering against developers and publish a package with a very similar name to legitimate ones. So in this case, someone published a bunch of packages, I think with underscore between two words instead of hyphen. And so this package was doing exactly what I was doing to scan your environment variables and sending to his own backend. Of course, the account got banned straight away. And to be fair, the attacker wasn't really subtle about what he's trying to do. So, well, the clues are there. And turns out when I look a bit further with npm, and there's other scary stuff. So it turns out when you can actually run npm install script and do this. So I guess in one sentence, life is terrible. and then with npm, I also found out that, hey, by default, when you install a package, there's this little caret sign. And what it means is that when you run npm install on, say, your CI box, it's not going to install that specific version, but it's going to install the most up-to-date version that's compatible with the constraints that you have. So in this case, I can actually install version 1.1.0, even though in my local development, when I'm working on my project, I'm using version 1 locally. But when it gets built, it's using the latest compatible version, which means in between me downloading the package locally and working and testing things are all working fine, to it getting built on my CI box, someone could have published and compromised the package, published a new version, and then what I actually end up running in my production environment is different to what I have locally, and I could be compromised without even knowing. There you go, what I said. So yes, life is terrible. I actually probably could as a developer. And so I guess the takeaway from that is you should definitely use npm string wrap, or if you're using old version npm, just update to the latest version. So nowadays npm by default it has much more stricter requirements, and you can ask npm to use the specific version, so that when you run npm install, you restore to that specific version as opposed to the latest compatible version. And this, of course, this problem is not specific to Node or to npm. I've worked with Java. I've worked in the JVM world. I've worked in the .NET world. The same problem exists in all those environments. In fact, one of the nice things you have in Node.js is that all the dependencies are just text files, ultimately, that you can look at yourself. So if you think something dodgy is happening, you can look at the file yourself and really easily figure out what's going on. With static languages like Java, Scala, or C# or anything runs on .NET, all you get is binary. So now you have to take the extra effort to decompile that to actually figure out what the source code is actually doing. So it takes more effort for you to figure out what's going on inside those dependencies. So now imagine the attackers managed to get into our environment, and our first line of defense is gone. Doesn't matter if you've got a VPC in front of that. What can we do? So the next part of that, the next line of our defense is our IAMs. So in this case, we need to control who can invoke our function, and also, more importantly, what can our functions access. So that's where the principle of least privilege is your best friend. And one of the common mistakes I find people make in the AWS is that, okay, you've got this setup where you got your public-facing, your public VPC, and you got your private VPC, and your internal services that are only intended to be called by your own services in the public-facing layer. And you have some VPC peering maybe, and then you assume that, okay, because nothing else can call these guys, so we are safe, we just need to put our protection around here in front of the public VPC. So anywhere here is fully trusted. This is the holy grail. As long as the attacker can get in here, they can access whatever we have on the other side as well. So again, if you're not careful, if someone manages to get in through an injection attack or through one of your dependencies, then all this networking protection you think you have means nothing. And of course, one thing we've seen more and more now is attackers stealing your AWS credentials, because they don't care about the private data you have. What they care about is getting some EC2 time to do some Bitcoin mining and make some money that way. And of course, if you're not careful, you're going to wake up the next morning and find a massive AWS bill in your account, which when I search for those similar outages, those similar incidents, I found so many of them. And in fact, even in my small social circle, I know of 2 large companies that has had this happen to them, whereby the accounts got compromised and the attackers used to rack up over $100,000 worth of AWS bill within a very short space of time. Of course, in that cases, there were big customers to AWS, and AWS agreed to cover the cost, but you have to be very lucky. And also, you just don't want to be in that situation in the first place. And with Lambda functions, even though everything is public all the time, but you can control who can invoke the function through IAM. So that's great. So on the front, we don't need to have other networking layers in front of that just to be sure that no one can get in. But as we mentioned, people can get in from the sideways through your dependencies, through somehow accessing or compromising dependencies that you use or dependencies of your dependencies, and they can still leak information from through those dependencies, as I showed you earlier. So what can we do? One of the guys that's in the serverless security space, PureSec, they publish a free library that's endorsed by this very handsome man. I wish I know him. And whereby this free library you can download for free and use in your packages that disables outbound internet connectivity by default. So your function can still talk to AWS services, but it can't talk to, say, arbitrary endpoint that the attacker has set up. And also it disables other things like the ability to create the child processes, as well as the ability to read and write to the temp folder, which is not something that you need to do most of the time anyway. And all of these options are configurable. And one of the things I've been doing now as well is wrapping the configuration and for this for function shield into a middleware, so that I can then distribute them a lot easier to the rest of my team, so that they can very easily use incorporate this as a default template for all of the functions they're working on. So with this very simple thing, I can then stop any unintended outbound internet connectivity from my functions. And then the reason why you probably don't want to use VPC with Lambda, at least right now, is that when your Lambda function ultimately still runs on some form of container, so when a new instance of that function runs, you have to go through this whole bootstrap process, including creating ENIs for your VPC. And that process itself can easily add 10 seconds to your cold start time. This depends on a number of factors, including how much memory you give to your function, because the more memory you give to your function also means the more CPU cycles that it's going to get as well. So it does help, but then still, VPC alone, you can add easily anything between 3 to 10 seconds from my experience. And as we mentioned, even if you have VPC boundary, it still means that anyone that compromises your function somehow can still access anything else that your function is able to. So one of the other things that we should definitely do is to implement authentication for internal services, so that when your, say, user-facing API needs to talk to some internal service that's only intended to be called by those user-facing APIs, then make sure you also have authentication set up in that communication as well. And when you're building APIs with API Gateway and Lambda, you can do this really easily. API Gateway, even though it's always public, of course, you can now also put them into VPC as well, but it takes a lot of effort, and it's not something that I tend to do normally. And you can also implement authorization and authentication in a number of different mechanisms for user-facing APIs. I tend to use something like Cognito, or using a custom function so that I integrate with other providers like Auth0. But for internal APIs, I tend to use IAM, so that anything that needs to talk to this API, I can control the access through Amazon's IAM mechanism easily. And if I'm building my APIs with API Gateway and Lambda using the serverless framework, I can enable that authorization with just one line of code in my serverless.yaml spec. Another thing you've got to do is make sure that you really minimize the amount of access that your function has. And this is where you really want to have one IAM role per function, and tailor that policy for that function to just what that function needs. And fortunately, again, some of the guys working in the serverless security space publish another free library that you can use. In this case, it allows me to use the serverless framework and specify an IAM role for each of my functions. In this case, if I've got a function that needs to get some object from the particular S3 bucket and put some object into a different folder in the same bucket, then I can specify very specific permissions for that particular function. Of course, all of these require developer discipline, and it's easy to forget them. So one of the things I've been trying to do in my current workplace is that we're trying to build tools to make this adoption easier, and so that you can do the right thing by default. And some of the vendors in the server security space, like PureSec, I've mentioned them already, but then there's also a few other guys like Protego. They're also building commercial tools that also does things like looking at scanning your code to see how you're using the AWS CK to talk to AWS services, and then compare that with the permissions that you're actually giving your function to see whether or not your functions are over-permissioned. In this case, you can visually find out that, hey, that function has got permission to talk to DynamoDB, even though in the code it doesn't actually talk to DynamoDB at all, so I should remove that permission. And they also tend to do active protection, so scanning the invocation event for your function. So if an event coming in from API gateway to your Lambda, and it looks like someone's trying to run a SQL injection attack, then they can put a stop to the invocation right away. And then there's also other companies like Outseed and CloudZero that focus more on the sort of visibility side of things from a high level. And one of the things you also find with Lambda is that you tend to write them in a stateless fashion. For one thing, you don't have much control over how many functions are running at a time, and also how long that function lives on for. So you typically write your function in a completely stateless way, and then you end up using a lot of different managed services to manage the state that you have in your application, including all kinds of different databases, as well as S3, and so on and so forth. And you also want to make sure that any sensitive data that you have, data about your customers, they need to be secure and encrypted at rest as well as in transit. And of course, with AWS, you get a lot of goodness out of the box. So many of their services provide server-side encryption, but you still need to use it and enable them yourself. For example, S3 supports managed encryption with KMS, so there's some types of databases in RDS. And more recently, Kinesis also supports, and DynamoDB as well now supports server-side encryption out of the box. So again, important to remember with Lambda is one of the most important things you can do from a security perspective is to make sure that you apply you restrict what the function can do. And also, people often talk about, okay, when your function is no longer needed, you should delete them, because anything that hangs around your environment is still an attack surface that someone can exploit. And that is one of the advices from the best practice guide from the Lambda documentations. But what I found is that, especially with Lambda, this is a lot easier said than done. So if you work in a large company, chances are there's going to be so many different services scattered all over the place, and it's often not easy to identify owners for those components, especially as people move around the organization or they leave the company altogether. Imagine you taking those service components, now breaking them up into even more smaller units of deployment, individual Lambda functions. So if you don't have a good way to organize them in some way and to find out what functions are in your account and who are the owners, which you can do through simple tagging as a very simple technique to do that, then chances are it's really hard for you to try to understand whether or not some function is actually being used. Is it not being used because it's only used for some failure cases that we just haven't seen yet? What if it's to do with disaster recovery? Now we delete the function. What happens when we do have a disaster? So identifying those ownerships for individual functions becomes a challenge, especially for large organizations. And we also have to think about now service attacks still. Even though with Lambda it's super scalable, I've heard a few times where someone been attacked, someone has was the victim of a denial of service attack, but hey, Lambda just scaled all the way to thousands of concurrent executions, so they managed to get through it. They brute force through the whole denial of service attack, but end up costing them a lot of money. And all the Lambda executions are not free. If you're using API gateway to expose the Lambda functions, API gateway itself is also not free. In fact, it's quite expensive by comparison to Lambda. So I guess you kind of go back to the world of, okay, well, I'm gonna have to choose, become unavailable to some of my customers when someone attacks me, or have to brace the impact of my wallets. Amazon does have AWS Shield service, but it still doesn't protect you from your APIs directly. You could have your API gateway. Nowadays, you can use a regional custom domain name so that you can have your own CloudFront distribution, which has now means that you can use Amazon's WAF service, which you can configure some of the rules around identifying spammy IP addresses and then block them. So when it's just, when an attack is coming from a single IP address, great. When it's coming from a really distributed set of IP addresses, I don't know how much that's actually going to help you. AWS Shield Advanced also, if you pay a monthly fee, it gives you some payments protection against some of the services that you incur when you're being attacked. But right now, it doesn't cover the cost for Lambda and a few other services. And also with Lambda, you got to think about when you have async event sources because they've got retry out of the box. So if someone has managed to execute an attack against you that somehow triggers all these retries in the background as well, then you kind of become a double whammy on top of the denial of service attack they're executing already. And you end up costing you a lot more money as well. So even with serverless, all the scalability that you get, all the cost per invocation, nice, the pricing you get, you still have to think about what happens when someone does attack you. And with server, we all know that at some point our server is going to be infected by viruses all over the place. So no server, it's great news. So one of the nice benefits you have with serverless is that you don't have to worry about having servers that live for a very long time. However, your Lambda functions themselves are still reused. The containers underneath your Lambda function, they are reused for performance reasons. So every function also has got access to a temp folder, and you should definitely avoid putting any sensitive data in that temp folder because that gets persisted between container invocation while the container is live. So anyone managed to execute an injection attack against you, they can also grab whatever from the temp folder just as easily as they can scan what's in your environment variables. So that's where libraries like function shield becomes also useful as well, so that you automatically by default you disable the use of the temp folder altogether. Yep, function shield there, you can check it out. Another thing I find with a lot of the traditional web frameworks is that it's easy to just leave directory browsing option on, and then we found, oh, okay, we can actually search Google and find the people's find all kind of wonderful things like when I search for SQL database credentials, app configs, and so on, app configs with credentials for the SQL databases in plain text. All of that happens because someone's accidentally left the directory listing option on when they're developing their web application. And again, it's a simple thing to fix, but when you're not careful, when you're not thinking about it, is those kind of mistakes can creep in. And I also found the cases where you can actually search and find someone's SQL dump right there in their root folder. So now that you don't have web frameworks that does that for you out of the box, it becomes directory listing becomes a feature that you have to implement yourself. So chances are, once you have to think about, oh, do I actually need this, you're probably not going to do it. So what I found with Lambda, at least, I've never had to do anything along the lines of implementing directory listing myself. So therefore, I have no chance of accidentally just exposing directory that contains important information that I have for my function, even though I still have to concern myself with, making sure that I don't, when someone does manage to get into my function, they can't leak information from my function, including the actual code for my function as well. And the last one to touch on, just about on time, is Bitcoin mining. I mentioned already, you got to be really careful in guarding your AWS credentials. I think, a couple of examples here, whereby someone just accidentally put the AWS credentials into a public repo, even for a few minutes, and then they found that, okay, even though they changed it, push a new commit, because all those commit histories are there forever, so attackers can still scan them. In fact, I know for a fact that AWS actively scans all public GitHub repos, and they email you, or they get in touch with you somehow when they see there are active AWS credentials in public repos in plain text. But they're not the only ones doing it. They're not the only ones looking. And I think in this particular article, the person left the AWS credential in plain text in the public repo by accident for about 5 minutes. And even though he fixed it right away, the attacker still managed to get that in time and get access to his AWS accounts. So one of the things you could do when I was trying to find, when I was searching for solutions, is that you can hook into the Git, Git pre-commit and run some script to check, to scan your code and see that you're not putting any AWS credentials in there by mistake. And also with AWS, you can set up monitoring so that if you only run infrastructure in, say, in Ireland. So you want to put alarms around any EC2 activities in regions that you're not using. from what some of the AWS guys tell me, I think Sao Paulo and Tokyo are the hotbeds for attackers launching EC2 instances to do Bitcoin mining, because those are regions that not many people use. So one of the things you could do in this case as well is you can set up alarm billing in regions that you know you're not using, as well as other alarms that you have for those regions. And finally, you want to apply bulkheads, which is a pattern for compartmentalizing leaks, and it's also a pattern that's been made popular by the Release It book by Michael Nygaard. So in this case, you want to make sure that your functions has got the least amount of privilege possible, and also isolate them per function, so that each function has got its own policies. And also you want to use separate AWS accounts. Personally, I like to have one AWS account per team, so that the team can own everything they have in their environments in terms of being able to be in control of their own infrastructure. But also it means that if one account gets compromised, not the attackers can only access the worst, whatever's in that particular account, as opposed to everything they have in the entire organization. So quick recap. Application dependencies is a much bigger attack surface than you probably realize, and the OWASP top 10 is just as relevant as before. And we need to sanitize our inputs from our functions as well as the output. And we want to apply the principle of least privilege to how we permission our functions, and we want to use one IAM role per function. And we need to make sure that any data that we're using for managed services, they are encrypted at rest as well as in transit. And when you know a function is definitely not being used anymore because you're the author, you delete that function right away. And the now service still a vector that we need to consider. And even though there is AWS Shield right now, AWS Shield Advanced doesn't cover the cost for Lambda just yet. And the servers, they tend to be infested. So no server means that we don't have to worry about having long-lived compromised servers in our environment. But we still got to guard our AWS credentials with a lot of care, so that we don't end up being victim for some Bitcoin miner somewhere. And finally, use account level isolation in your organization. And remember that people is still the weakest link in your entire security chain. So with that, thank you very much, guys, for listening. We've got like three minutes for questions, but I'm going to be around later for during break and lunchtime as well. So if you've got any questions, come and grab me in the halls. I guess, any questions?
I guess that was all clear.
Okay, cool. All right, let's go to break then. See ya.